will start from there. Good morning again, and let us continue with the next point. By the way, if you can recall, we started with something like a method overriding yesterday. So let's quickly recap what we have seen yesterday, and then we'll take a look at new functionality, which I mentioned yesterday, something regarding operator overloading. Okay. To understand operator overloading, it's important to understand what method overriding is. So method overriding is the way you are adding your own implementation in derived class. So base class gives base class gives a method, and it has its own implementation. But if you want to add something on top of it, then you can override that method in a subclass or in a derived class. That's what we mentioned yesterday. So let us continue with page 1. Let's create a simple example one more time and see how that method overriding can be used in the real world. And then probably we can take an advantage of method overriding, and then we'll see what exactly do you mean by operator overloading. Let's take an example again, maybe say something like a class car, for example. This class car is going to have some car attributes like car's model, maybe a very simple let's say cars, simply like a company, for example, and something like a car's price, for example, again. So self underscore model. I hope you can understand I'm using a single underscore. Single underscore simply means it is a kind of protected member, and when I say it's a protected member, probably you can see that it can be used only within the same class or within the derived classes. So this is a model again, self underscore company, which is equals to company, and self underscore price, which is equals to price. As simple as that. Now by default, I want any car to print its own details. So very simple. I'll say this is going to be print info. I will not do anything. I'll simply say pass. So I'm specifying like any car who is going to get derived from a car class should go for a kind of maybe implementing its own information. Now, instead of saying class car, I would just change this to something like a vehicle. So because I know car is a vehicle, again, something like bike is also vehicle, and so on and so forth. So I'm going to go back here and say this is the bike class, which is derived from a vehicle class, because bike is also a vehicle and car is also a vehicle, you know. So this is the vehicle class, and sorry, this is the bike class, which is going to have, you know, initialization of its own model, company, and price. And along with this, probably it's okay, I don't need anything other than this. So probably I'm going to say vehicle vehicle dot underscore init, pass self, model, company, and price. That's it. Again, maybe we'll have to provide the print information method or print info's implementation here, which I can easily do it by having some basic information like say this is the bike information, because I know it's a bike. So I'm going to specify that it's a bike information, and precisely I'll print all of this information like this. Say this is the model, which I can easily get it by saying self underscore model, not module. Okay, print the other one is the company, which I can easily print it by saying self underscore company, and finally print this is the price, which we can easily do it again by saying price. That's it. Now we'll go for a car class, which is again a vehicle. So maybe I can say car is vehicle and bike is a vehicle. So basically this is what is a relationship is all about. So probably I'll go for here. I'll say this is going to be the model. Say this is company, company and price. And along with this, I'll also go for a fuel type, better. So basically, if you're using a car, then what type of fuel it is using? Is it a petrol, is it diesel, or what else it is? I mean, the organic fuel or whatever, for example. So again, I'll have to call that initialization method for vehicle, where we can pass the model, company, price, that's it. And we can also put this the fuel type inside the car. So probably I'll say fuel type is equals to fuel type, as simple as that. Now being a car, I'll have to print my own information. So probably I'll have to go back here. I'll say that this is the print info. It's not a bike, it's a car information. And along with this, I want to go for say its own implementation kind of stuff. Maybe I'll say it's the fuel, and then I can pass the fuel tab. So this is how we'll write two classes. So these two classes, car and bike, both of them are derived from the same base class. So this is an example of hierarchical inheritance. So yesterday, if you can recall, we talked about 5 different types of inheritances, and this is one of the examples of them called as hierarchical inheritance. Let me create a vehicle, maybe a car vehicle and a bike vehicle by saying B1 is equals to bike. Okay, maybe what am I supposed to pass? Model. Okay, let's say Activa. Maybe Activa is from whom? Hero, I guess. Hero Honda or what? Honda, not Hero. It's Honda Activa. Company, and the price, let's say 75,000, whatever it is. And then we can say B1 dot print info. Similarly, I'll say C1, which is equals to car, and probably I'll go for a car's model, let's say i20. This is a Hyundai, and probably it's 7.5 lakhs, whatever, or maybe 7,500, 75,000, not 7,500, 75,000. That's it. 750,000, sorry, my bad. And again, it's as simple as print info. So basically what we are doing here is we are creating a kind of oh, I need to pass a fuel type as well. Let's say this is the petrol car. So we are trying to create a bike information or bike class and a car class. And probably we can see that here it is printing the bike information, here it is printing the car information. Naturally, it will call print info from the bike class and print info from the car class if you're creating an object of car or if you're creating an object of bike. So what we are trying to say here is car class is overriding. Let me just go back here and say it is overriding the print info method. That's it. This is what we are saying. And again, in case of bike as well, we are saying bike class is also overriding the print info method. So in this case, we are trying to say vehicle as a kind of maybe something which you cannot just guess. Vehicle is a general vehicle. I mean, you cannot just consider anything when you say vehicle. Anything is a vehicle. Car is a vehicle, bike is a vehicle, maybe a bus is a vehicle. All of them are vehicle. So when I say bike, I know this is the bike I'm talking about. Or when I say car, I know there are 4 wheels or it has its own shape and blah, blah, blah. So when I say vehicle, nothing comes to my mind because vehicle is a vague idea, while bike and car, both of them are real entities. So both of them are sharing some information like model, company, price, and that's a reason why we thought of having the vehicle here. Okay, so this is one way to implement it. Generally, this is something which we generally prefer when we have two completely different implementation of that method. But in this case, I think there are a few things which are very common and we are printing in both the classes. So you may decide to go back and put this information here and call the print info of vehicle class. So probably you can say vehicle and say print info self, and instead of printing all of these details, we can call the vehicle print info self. Again, naturally the output is not going to change. It's exactly similar. The only difference here is instead of implementing both the methods having similar code, we try to put the common code inside our superclass or inside our base class method print info, and then we started calling it from both the derived classes, bike and car. This is how we have solved a very simple method overriding problem. Now in real world, you can think about a base class providing a method and the derived classes implementing its own definition or giving its own definition for that existing method. So this is how the method overriding is implemented in the real world. I hope you are getting it. Now, before we go to the next point, I just want to highlight one thing. I mean, I don't know whether you have noticed this or not, but let me just go back here very quickly and say, I have a very simple class, a class person. Look at what I'm trying to show you here. So this is the class person, and probably I'll simply say there is nothing. It's a completely empty class. There is nothing inside it. There is an employee class, for example. I'll say this is an employee class, which is derived from person. Again, there is nothing here. It's very simple, empty class. And probably I need one more class. Let's say this is a manager class, and this is going to be inherited from employee. You see, as simple as that. There is nothing here. Okay, so when you talk about these 3 classes, I want to say who is the base class and who is the derived class. So precisely, I'm going to come back here and say base class for manager. Who's the base class for manager? So probably I can say manager underscore base, and this will tell me who's the base class of manager. Similarly, I'll go for base class of employee, and here we can say employee underscore underscore base. So when I say run this code, I would see that manager is derived from employee. So employee is the base class for manager. Employee is derived from person. So person is the base class for employee. This is something we already have discussed many a times. But what I want to show you here is a little bit different. You didn't ask that question, or probably you must have asked, but I said I'll cover it later. Anyways, I'll talk about this now. So what is the base class for person? I mean, I know here manager is derived from employee, that I can see here. Employee is derived from person, I can see that on line number 5. But I never have said a person class is derived from any other classes. So what can be, or in this case, what is the base class for person? Is there any base person class? By looking at it, I think we don't have anything here. That simply means it doesn't have any base class. And this is true when you are using Python 2.7, I mean Python 2.x versions. Now, starting from Python 3.x, the version we are using is Python 3.7 or 3.8, whichever you are using. But when you are talking about 3.x, any version starting from 3.0, every single class in Python is derived from, let me run this code and you will see that every class in Python is derived from an object. So basically, whenever you are in Python, all classes are derived from object, where please take a look at it. O is small, it's not capital O, it's a small o. So this is the class which is given by Python, and this is by default the parent class of every single class. So probably if you think about this, maybe I can just go back and I can write it myself as well. I mean, I don't have to, because by default it is derived from object. So you write it like this way. I'll give you a couple of options for you so you can understand. Many people like this way, or this way. So either you write this way or you write this way, something like this, or maybe I'll do it in this way, or you write in this way. So basically, even if you put a even if you put a empty parenthesis, still it is by default considered that you are deriving this class from object. Or maybe you can do it from this way. I mean, you use this or this, and you will see that by default it is derived from object class. Now, I hope you must have got the things clear. Like whenever we are creating a person class object, say P1 is equals to person, why we put the parenthesis there? So we put the parenthesis simply because by default, even if you are not writing this, it is going to be written like this. This is the way any class is kind of created in case of Python. So basically, this is the person's class definition, and it is having its own parenthesis. Within parenthesis, it is getting derived from object. Please remember, object is the base class for all classes in Python. What do you mean by this? Very quickly, I already have shown you that yesterday as well, but very quickly, let's go back here and say we are having 3 classes. I'm sorry, let me go for the other one. So we are having 3 classes here. So let me just put their names, like this is the person class. Okay, so this is the person class, and probably I'll go for another 2 classes. The other class is employee, and other class is manager. So basically we are having 3 classes here. On top of it, there is one more, something called as an object class, and object O is always small. Please remember this. So this is the hierarchy right now. So actually speaking, and to be very honest with you, there is no simple inheritance actually when you're talking about person and employee. This is a kind of a multi-level inheritance. So this is a multi-level. I know that this is something we already have discussed it earlier. So this is a hierarchy where we can say one class is derived from another. So if you just put a relationship here, object person, then person employee, and employee manager. So if you put a relationship, manager is derived from employee, we saw that last time. Employee is derived from person, we saw that last time. And just now I showed you that person is derived from object, something like this. So whenever you are not specifying anything regarding the base class, by default it will be object. Just give it a shot one more time. See, I'm going to show you here, it's not required. So probably I'll go for one more class. Say this is a class car, the one which we just have created. Again, there is nothing inside it. It's an empty class. But if I try to print who's the base class for car, you will see that base class for car is again car dot underscore underscore base. And if I say run, you will see that because I didn't mention anything for car, it's showing me the car is having a base class as an object. So object is the one which provides all the default properties for any class, and that class is going to get all the methods either overridden, or maybe you can say it's kind of giving you all the functionalities there. I hope that makes sense. And if it is making sense, now I'll show you something. By the way, have you understood this, guys? Have you understood what I just showed you here? Okay. So if you have understood this, probably only a couple of you are saying yes, but it's okay. Yeah. Now, if you have understood this, there is a meaning to it. I mean, I'm not just telling you just for the sake of information. There is something which I want to show you, which is kind of important when you go for other languages as well. So understand what I'm trying to show you here. Now we already have said here, by default, every class is derived from person. It's like you might have heard about that sabka malik ek. So probably here, when you talk about all the classes, every single class is derived from object. So sabka malik ek, and that malik is nothing but the object here. Okay. So you might wonder, like, why on the earth they have decided to do like this? I mean, what have they achieved by using a common class called as object? What is an advantage of it? Now, let me show you an advantage. Now, when you go for that object class, probably you have not seen it here, but if I just go back here and write it, and if I open this here, this is the class which is given by Python. And Python, look at this class. This is the Python source code, and the Python source code has given that class object, which is having many different methods. Do you see that? Underscore underscore dir underscore underscore, that's a pass. Yeah, this is a kind of dunder eq, dunder format, dunder get attr, dunder ge, gt, so on and so forth. There are many methods given by that object class which we can use in case of our application here. One of them is like set attr, and one of them is like get attr. You might see it somewhere here. Do you remember last time we were calling methods like sorry, not methods, functions like set attr and get attr. Those internally would call these methods underscore underscore set attr underscore underscore and underscore underscore get attr underscore underscore. Anyways, not important at this moment. For me, the important is this one. See what does it say? It says like this is the method. By the way, def underscore underscore str underscore underscore, that simply means this is the method, and this method is supposed to do something. I'll show you the real example of it, why it is so important to understand what I'm just trying to show you here. Okay, just see this. Now, whenever you are talking about a car class, probably you have seen that the car is empty class right now. So maybe I'll just add only a couple of things here. Let's say I'm going to add, say, model, for example, company. That's it, more than sufficient. I'll say underscore underscore model is equals to model. I'm not going to have any kind of derived class after it. So I'll just make it private so that no one can access my member external. So company is equals to company. Maybe I'm going to create an object of this car class saying C1 is equals to car, and say this is I-20 again. The company is Hyundai. That's it. Okay. Now see what I'm trying to show you here. Okay. First, we know that the cars base class is object. So let us again look at this. Cars base class is object. This is confirmed. Now I have an object of car class, that is C1. Along with this, I'm going to create one more. Let's say num is equals to 100. Now, when I say num equals to 100, you know that this is of type integer. I'm sorry, this is of type integer, and this is of type car. So basically, the type of num is integer and type of C1 is car. And let me just confirm that again. So print f, this is num equals to num, and then again type is equals to the type of num. Let's do the same thing for C1 now. So C1 is equals to C1, and probably type of C1 is equals to, let's see what does it print. So when I run this code, probably you can see that the num is equals to having a value 100. At the same time, the type of num, you know that it is a kind of integer. Now look at the way C1 is showing itself. So when I say the C1 is equals to something, it's not showing me the object properties. It's not telling me anything about that car's object. It just tells me that this is a generic object. This is a generic object of car class, which is loaded at this address. And of course, the type of this C1 is nothing but a car. Understood? This is an object of car. It's okay to look at this information. but nowhere I see what is the value or what are the different attributes I have stored inside that C1. Look at the num. Num tells me that the value 100 is stored in num, but C1 doesn't tell me what is stored inside it. The simple reason behind this is because num is kind of made to store a value, while C1 is made to store an address of an object. We already have discussed this earlier. But what if I want to display this information like what num is showing? So num is showing the value within it, and if I want to print that C1, I want to also see the value which is stored in that object. So how do I do this then? Now to do this, let us ask this class integer. By the way, you see here num is 100 and 100 is like an integer, and that's the reason num has got a type of integer class. By the way, did you remember I mentioned something like there is no data type in Python? I mentioned that earlier, and I said that I'll mention something about it once we are done with the actual object oriented. Akanksha, sorry, Akshata, just wait for today, tomorrow, or maybe end of the day today, you will be able to see what exactly that underscore mean underscore is. Okay, that's the name of the module, by the way. But anyways, you will get the answer either today, late today, or maybe tomorrow morning. Okay? But before we talk about this, I have a question to you. In fact, I hope I mentioned this earlier. There is nothing called as a data types in Python. So basically, when you talk about the Python doesn't have any data type, and this is very true. I mean, Python and similar languages which are going on the similar lines of Python, they do not have any data types. There is another language which is very famous in data science or machine learning called as R. So there also you will find the same thing. There is also no data type. So did I kind of fool you last time? I mean, did I lie last time that there are 6 data types and 5 data types? Not really, actually. When you come from C or C++ or when you come from Java, all of them you consider as data types. To be precise, they are not. I mean, when you talk about the Python, in Python, there is no data type. So let me show you what exactly happens behind the scene. When you create a variable, so probably when you create a variable like num equals to 100, Python behind the scene looks at the type of 100. It says, okay, type of 100, it seems like it is an integer. So what does it do? It creates an integer class object, puts the value 100, and it says that this num is pointing to that class integer. Please understand this one more time. There is no data type in Python. Whenever you are creating a variable like num equals to 100, by default, it creates an object of integer and it puts the value 100 there. Oh, means like I am creating an object of car behind the scene. Let me show you here. Behind the scene, Python is going to do something like this, integer, and then inside it, it is going to store the value equals to 100. Which means if I look at the actual implementation in the memory, it looks something like this. See, when I say num equals to 100 or when I say car, both of them are representing the similar information, just a small difference. I'll show you the difference as well. See, this is the num equals to 100 and this is C1 equals to car, whatever, I-20 and Hyundai. So basically, if you look at this from the memory perspective, again, it's doing the exact same thing. So this is a num and this is an object of integer. So this is an object of integer class. Same thing, this is a car's C1, that's a reference, and this is an object of car. So probably if I just go back here and say this is a kind of 0x, again, the same story, there is no change here. So probably I'll just say that this is 0x 10,000 probably, and I'll put it right here. This is a kind of an address. Again, 0x 20,000, that's it. This is the address of a reference. Probably this is 3,000, I'm sorry, 30,000 here. And let's say there is a 40,000 here. So probably as you say here, this is 40,000, 40,000. Everything is going to be exactly similar to it's matching whatever discussion we had earlier. So everything is same. The only difference is one object is created by me and the other object is created internally by Python. So whenever you are talking about this num, the num is having a value of 100. This is the only difference. And probably that 100 value is going somewhere here. That's it. This is what happens internally. So probably when I go back to that car, the car internally is storing the data in terms of this model. I'm sorry, model is equals to I-20, for example, and the company, which is equals to Hyundai in this case. Okay, so when you talk about something like this, there are two attributes, one model and two company, and both of them are stored right inside of this. So this is what internally happens when you are creating an object of car and num class or integer class. It's like you are not creating an object of num class, it's getting created automatically. So whenever you assign a value 100, Python is intelligent enough to understand, okay, it seems like this matches with the definition of integer. So it creates an object of integer class. Oh, I forgot to mention that. This is an integer class object. I'll say integer blah, blah, blah. And this is created automatically for you. Similarly, this is a car class object. There you are creating it explicitly by saying C1 equals to car. This is how we are creating it. Let's take another quick example of it. Maybe I'll say something like str, not str. So let's say name is equals to str. Maybe I'll say something like a test, for example. And if I try to do it, say this is going to be the name, this is going to be the name, and this is going to be the name. So when you say run, you know that it is going to be a class str. So precisely this is again behind the scene creating an object of str. So again, let me just go back here, copy this, mention it here, what exactly is happening behind the scene. Again, same story, no change, exactly same story. Behind the scene, it is creating an object of str class. Str is a class which is given by Python, and those classes are by default managed by Python. You are not going to do anything for that. So all of that will be managed automatically behind the scene. So for you, you don't have to do anything for this. So that's the magic behind it. Let me just go back here. I'll say 0x50, sorry, 0, so what the hell, 0x50,000, for example. I'll mention it here. So the 0x50,000, again, as usual, it will be here, it will be here, and 0x60,000, for example, which is an address of this reference, which is nothing but name, which is again a kind of a reference for me. We already have discussed that turn of times now, reference somewhere here. And then this is a class str, and this is an object of str class, you know. So this is how the Python internally is managing the stuff. So this is num, for example. All what we have discussed earlier is going to be exactly true for num1, I'm sorry, the num and str as well, or num and the name as well. So everything is going to be exactly similar. The only difference is here we are creating an object ourselves, means explicitly, and here the object is getting created internally, or maybe it's getting managed internally. So when you say test in double quote or single quote, or when you say 100, or when you say something like 50.5, then internally Python looks at the value and it decides which class object it has to create, and it creates that object accordingly. So that's what Python's duty to do it on behalf of you. So you are not going to create an object of integer, or maybe something like string, or something like boolean, or something like decimal. Everything will be managed by Python. The only difference between these two is this is an explicit object created by you, and this is an implicit object created by Python. Okay, that's what I said. There is no data type in Python. I mean, what we see here, that's integer, str, and all of that stuff, these are all classes. Behind the scene, every single num, name, salary, all of them are nothing but references. All of them are managed as references, objects of different classes. Okay, so hopefully you are getting the information there, Preeti. But for data types, these are the kind of wrappers. It's not like these are kind of the wrappers. These are the actual classes. These are the objects. So I think you are coming from Java, and probably in Java you might have seen that small I and capital I integer. That's why you are asking whether it's a wrapper class or not. To be very precise, when you are in Java, you are having the value types like integer, float, and something, something, something. There you have the wrapper classes as well. Here there is no integer or float data type. Here what you get directly is the class object. So even if you are saying 100, it's not a native data type, it's not a native value. It's simply an object of integer class, and that's what you are getting it here. So behind the scene, it is implemented as a class integer. You may say that it's a wrapper class, but when you say wrapper, there has to be something which it needs to wrap. To be very precise, there is nothing called as integer or float or string in case of Python. Everything is an object. Everything is an object of a class. And that's the reason why sometimes people say that everything in Python is an object. To be precise, I already have mentioned this earlier as well. Everything in Python is an object, but to create an object, you need a class. So everything is internally implemented as a class. Okay. Prashant, what command are you using to press to get all details of class object? No, nothing. I'm not using any command. It's just a simple, oh, this one you are saying, control and click on that. So control and click on any class and you will get all information. So probably you're talking about getting an information of an object, right? So you say control, click on that, and automatically it will show you the information about that class from Python's documentation, okay? Pranit, when you showed the documentation, there is a definition of a static and class method. Are you going to please? Yes, of course, yes, but not today. I told you, we have to talk about static and we have to talk about where the static methods are used. Hold your question, you will definitely get the answer. Okay. Shrikant, can we say that the object is a base class of class integer? It's not only the class integer, whatever class you consider in Python, all these classes are derived from object. So be it a integer, be it a string, be it a maybe a car, be it a vehicle, be it a bike, whatever class you write in Python, all of them are by default derived from object class. Okay. So Shrikant, that answers your question. Adesh, how will we get the type of those names and num when say type through the name and the num is references? To be very precise, when you say get type, it shows you the type of that class. So basically, internally rather, whenever you're talking about that maybe 100 or when you talk about that value test, behind the scene, all of those values are getting stored in those objects of those classes. So probably behind the scene, this is an integer class object getting created to hold that value 100, and string class object is getting created to hold that string value. So that's why you are going to see the class integer or class num and something like this. Okay. Okay, so object is a root class. Absolutely, Parag. Here, object is the root class. And when I say object, please remember here, objects O is small case, not the capital case. Okay. So when you say object, object is small o object, and that is a kind of a root class. Root class is nothing but the class which sits on the top. All the other classes in Python by default are inherited from object class. Guys, have you understood this? Please confirm. To create an object, we pass a value in the constructor. Then how the object takes the input from num equals to 100. That's the magic of integer. It's not like object is getting created behind a scene from num equals to 100. Python is smart enough to see that value is equals to 100, and that's the reason why it goes and tries to create an object of num. So Ketan, I know what question you are thinking right now. So it's not like looking at this, it creates an object class. It creates an object of integer class, but integer internally is derived from object. So object class by default gets created inside it. Try to recall the diagram which I talked about yesterday. And if you can recall, I said that every derived class will contain an object of base class. So every integer class, str class, car class, bike class, whatever, farana class, all of these classes of class objects will definitely contain an object of an object class. Okay. So probably Ketan, what you're trying to ask here is how it is getting created. That's the magic of Python. So Python looks at the value and it decides the type of that value or type of that variable on the, while running the application or dynamically or at the runtime. So that's what it does behind the scene. That's the magic of Python. So it looks at this and it says that, okay, it's a string. It looks at this and it says that, oh, this is nothing but a kind of integer. Oh, maybe if it looks at the true or false, it creates it as a Boolean. That's the magic of Python. Okay, good. Okay, so one thing is for sure, whatever class you're going to write by default, that is going to get derived from object. So that is something that you need to understand. Object O integer I is the small because the built-in classes, right? Exactly. So I was about to say that. That's what you need to understand. Like every single class you are going to write are, every single classes will be derived from an object class. But have you noticed something? I told you many a times that whenever you are writing a class, always use the class first letter as a capital. Now there is another reason behind it. Most of the times, I mentioned that earlier as well, Python lives on conventions, not the compulsions. So conventionally, Python's internal classes or Python's default or built-in classes generally start with small case, just to differentiate them from the custom classes. Custom classes are the classes which we, or maybe I and you, or maybe we as a developer create for our own use. So car class created by me, bike class created by me, vehicle class created by me. Just to differentiate these classes from the system classes or built-in classes, we generally start writing our class name's first letter as a capital. So this is another convention that you need to follow. And that's the reason why you see here objects O is small, integer I is small, strs S is small, booleans bools B is small, decimals D is small. All of them are starting with the lowercase letter. That's a kind of a convention Python always follow. Okay, Deepak? Yes, absolutely right. And this is what you are saying. Absolutely right. Pranit, it means looking at an empty array, Python calls an empty list class object. Absolutely right. So whenever you are calling that list function, or whenever you are using a kind of, let me just do it here right quickly. Maybe I'll say L1 is equals to square bracket, or T1 is equals to, no, tuple, you know that. This is not going to do anything. It's of no use, but still. And maybe I'll say dictionary is equals to curly bracket. So you know that looking at this, Python by default creates an object of a list class. Looking at this, by default, a tuple class object will be created. By default, it's not a set, it's always a kind of a dictionary object will be created behind a set. Okay. So Praneet, yes, that's the magic of Python. So Python magically understands, oh, it's a list. So it creates an object of a list class. Okay. Priti, it is the class of object, have object, but with the small o is an object of object class. When you talk about object, let me just go back here and try to complete that path. Try to complete that statement which I mentioned last time. So we saw that the base class for something like a car is equals to object. Let me just try to go for here and try to see what is an objects base class. You know, I was wondering, like, do we have any kind of objects base class set to anything? And you will notice that objects base class is set to none. None in a sense, this is a kind of an object which is having no parent class. So there is one class which is not having a parent class, and that is called as an object, which is the root class. I mean, the one where the actual tree begins is nothing but the root for us. So here, object is at the root class. I mean, generally when you are in computers, we talk about the tree not growing from bottom top, but growing from top to bottom. So even if you are trying to show a hierarchy, we see that this is the base class and there are derived classes. So it grows downwards, not the upwards direction. So this class doesn't have a base class. Please remember this. The class which does not have any base class is an object, and that's the only one case where you do not have any parent class. You do not have any base class. That's the only one exception. But otherwise, all the classes are going to get derived from object. Let me make a statement, see if you can understand. In Python, every class will be derived from object either directly or indirectly. When I say directly, see, car class is indirect. Car class is derived from object directly, because you see, car is having an object written somewhere here. Even if you do not mention this, you know that by default it is going to get derived from object. So this is the direct derived class of object. Whereas you see, employee is an indirect derived class of object, because employee is derived from person, person is derived from object. So employee becomes a indirect base class of indirect derived class of object. Manager is again indirect derived class of an object. So in Python, every class is going to get derived from object either directly or indirectly, depending on how you are writing it. So if you say only class person, this is the direct derived class. When you say employee, which is derived from person, and person is derived from object, so employee becomes indirect subclass or indirect derived class of object. Okay, good. Parag, EMP and manager are indirect. Absolutely right. So EMP manager, both of them are indirect base classes. I'm sorry, indirect derived classes of object. I hope you are getting it. Are you? Guys, are you getting it? Very good. Okay. Thanks for confirmation. Now look at what I'm trying to show you. Now I was wondering, like when I try to create an object of my class, let's say car, and if I try to print it on console, now I'm done with that base class. I'm just trying to see that information which I can, okay, it's already been written here. So if I try to put the num on console, it shows 10, it shows 100. When I try to put that name on console, it shows test. But when I try to put that C1 on console, instead of showing me what is there inside C1, it just tells me that this is an object which is referencing to this particular memory. That's it. Other than that, it doesn't show me anything. But how come it is? I mean, all of them are objects of object classes. Then why on the earth num shows a proper value, string shows a proper value, and C1 doesn't show anything? I mean, what is the reason behind this? One might say, oh, it's because this is the class which is owned by you, and this is the class, I mean, these two classes are owned by Python. Absolutely true. I mean, there's nothing wrong here. What you are saying here is Python creates those classes internally, and that's the reason why it's trying to put the value 100 and test directly when you put that num and name on console. But isn't it possible for me to do it? Isn't it possible for me to achieve it? The answer is yes, it is very much possible for you to achieve it. Just you need to know a small details about it. See what I'm trying to show, understand it, and let us try to think about that situation for a second, and let us fix our problem. When you see, let me just go back here, put everything in comment for a minute, and let's focus only on that num equals to 100. When you say num is equals to 100, I mean num is equals to num like this, behind the scene, this num gets converted into, because I said that num for me is an object of integer class, and integer class is already, I mean, just let me go back here and say integer. And if I click and go for here, you see that integer is derived from object. You see that now how to get the documentation of it. So integer is derived from object. So basically, if you just look at if you look at, do we have it here somewhere? New. Okay, let's go. RS. It's not showing it here. Maybe, okay, it's not showing anything here. That's okay. So when you try to show, or when you try to put that num behind the scene, because this is a reference, it calls a method called as __str__. So basically, what does it do behind the scene is this. Whenever you are printing num behind the scene, it calls this method __str__. It calls this method. Let me see what happens here. You see that even if I'm writing num, or even if I'm saying num dunder str, I'm calling that dunder str method, it still shows the same output. Let me try doing the same thing for the class str. Let me just go back here, say print, say dash, sorry. And let's add that maybe 50 times. So at least we'll have some differentiation. See, num is equals to test. Now, name is equals to test. Name is equals to test. Let me change this little bit and say something like this. You see, there is no difference. There is no difference because when you put name here or when you put num here, behind the scene, Python is going to pre-process your code to call dunder str method on that reference. So is it happening something like this on my class object as well? True. When you are writing this code behind the scene, it is going to call the str method on your reference, and that's what it is doing right now. Let me just go back here. Sorry. Let me just go back here and try to run this code, and you see that though you are writing C1 or C1 dot __str__, probably you are getting exact same output. Now, hopefully you are getting this point that behind the scene, Python is kind of changing this into this, changing this into this, and changing this into this. Now try to understand what statement I'm going to make now. When you say C1 is getting converted into C1 dot underscore underscore str underscore underscore parenthesis, that means the dunder str method is getting called on my class object. That's my C1 object. Now, if you can recall something which I mentioned yesterday, whenever a method is getting called, the method's existence will be checked on its same class first. Same class in the sense, it will try to search if dunder str method is available in car class, which unfortunately in this case isn't. So str underscore underscore str underscore underscore or dunder str method is not implemented by car. So what will happen? Will it give me an error? No, it will go to its base class. Now who's the base class for car? The car's base class is object. So it goes to object class, and probably you can see, you will not see all the coding here, but you will see that it is already having an implementation of str here, which is nothing but a kind of it's a kind of a method which by default prints something like this. It prints what is the name of your class, it prints object at and the memory where the class is loaded in the memory. So this is what your object class is by default printing. Oh, that's the reason why num is printing 100, name is printing test, and C1 is printing something like this. Which means because I do not have the method for or method implementation of dunder str, it is going to object and calling that method from there. Is there anything or is there any way I can stop that from happening? I mean, is there any way I can stop that objects str method from getting called? The answer is yes, there is. Just now I mentioned, when you are in object oriented, if you do not want your base classes implementation to be called, what will you do? You will override that method. So how will you override that method? To override that method, just use the same name of that method. That's it. It's underscore underscore str underscore underscore. That's it. Now, of course, what do you mean by this here is like overriding the underscore underscore str underscore underscore method. So we are overriding the dunder str method in car class. Now, just remember, when you are overriding that str method, it is mandatory for you to return a string here. Maybe I'll say underscore underscore str underscore underscore from car class. Last time I was getting something weird like this. Now, when I say run, see what happens. Look what it tries to show you. It says dunder str from car class, dunder str from car class, which means even if I just put a C1 here or C1 dot dunder str, behind the scene, it is anyways going to call that method for you. That now I understood how num is getting or num is printing 100 and name is printing test behind the scene. The rule is common to everyone. So when you say num or when you say name or when you say C1, behind the scene, Python is going to call underscore underscore str underscore underscore on all these references. If you want your object should return something valid like name and num, go ahead and override that method. If you do not override this method, by default, the method will get called from object class. And when it gets called from object class, you already have seen it. It doesn't show the value. Rather, it shows the object is owned by or object is created of a class, something like a car. And it says that, oh, this is loaded at blah, blah, blah memory location. So whenever you are trying to do something with the dunder str method on your own, this is said to be car is overriding str method. Similarly, integer has override the str method. Similarly, str has overridden the dunder str method. Similarly, decimal has overridden the dunder str method, so on and so forth. Parag, absolutely right. Guys, are you getting something? So, moral of the story here is, whenever you are in Python and if you do not like what it prints by default, when you say C1, then the simple way to fix this problem is to override that method. Which method? Dunder str. The way to implement that dunder str is very simple. Whatever str or whatever string you want to convert to, just convert that and return from this method. Now just saying underscore str from a car class doesn't make any sense. So probably I'll just go back here. I'll convert this into a better option. Say car, and right here I'll say model, which is equals to self underscore model, comma, what is that, company, and there we can say self underscore model, I'm sorry, self underscore company. That's it. So when I say run, now now it shows me the valid information, like this is of type car, it is having a model i20 and company Hyundai. Look, like num is printing 100, like name is printing test, the value inside that object. I'm also trying to print the value inside my object. This is in my hands, you know. So because I'm trying to do it as per my requirement, I can take the decision what needs to be written from here. Should I return the whole value? Should I return a name? Should I return a model? What should I return? It's up to me. Python's default classes or built-in classes like integer, str, decimal, boolean, they try to print the value inside those objects. Okay, so now you must have got maybe a clear-cut idea about what exactly is happening behind the scene. So as we say, like Python does not have any data type, but still we can create an integer, we can create a string, we can create a decimal. So what happens here? Python looks at the value and it tries to go for creating an object of that particular class, and then it assigns that class object to that reference. So this is what it does behind the scene. Exactly. Same as prototyping in JS. Not really like prototyping, but this is truly inheritance. In JS, prototyping is provided because JS does not support a class, and in JS there is no way you can go for inheritance, and that's the reason why there is a prototyping. This is not prototyping. This is a kind of real implementation, a real inheritance. The simple reason behind this is C Python is internally developed, internally using not only C, it's actually developed in C++. Because it's developed in C++, it already knows when to use classes, where to use classes, and it knows like what exactly the inheritance is. So that's not prototyping, that's pure inheritance. Prototyping is a kind of alternative to inheritance. Okay, Ketan? I hope you are getting it. Okay, so I think one more time, let me repeat myself. Whenever you are creating an object, whenever you are creating a class, the class is kind of a way to, way to put all of these attributes and all of the methods together. But when you do it and when you create an object of it, and if you try to put it on console, by default, it shows the class name and the object's address. But if I really want to print something better than that, I should always try to override the method dunder str. That's the way you should do the job. Okay, so if you have understood this, I think that's what you need. Other than that, you don't need to anything. I mean, you need to understand anything. That's the simplest thing you can think of. Okay. Okay, so now you know how to override a method and why to override a method. Let us continue further and let us try to think of different scenarios. I hope you can understand them pretty much quickly. But anyways, I need to show you a few examples. So this is page 3, for example. And let me just go for num1, which is equals to 100, and num2, which is equals to, let's say, 300. Maybe I want to come back here and say str1, which is equals to test, and str2, which is equals to test1 and test2. Very simple. Now, probably what I'm trying to show you here is like we are having few built-in class objects, that's integer and string. Now I know these are the two different objects. These are two different. These are two different values we are storing: 100, 300, test1, test2. But still, I want to give it a try and see whether I can perform some comparison operations on them. We already have done that earlier, but still, I just want to give it one quick shot. This is print again. I'm going to print. Let's num1 is greater than num2. So this is what I'm trying to do here. So num1 is trying to get compared with num2. Let me see what is the final answer. Num1 is greater than num2. Maybe I'm going to do the same thing if num1 is less than num2. Something like this. And probably I'll go for number is equals to num2. Very simple. And number is not equals to num2. That's it. So this is the way we want to try. Maybe we want to give it a try and see if it really happens in that way. So probably I'm going to say that this is greater than and greater than equals to, sorry, greater than and greater than equals to, something like this. And probably we can go for less than and less than equals to. So probably this is less than, sorry, less than equals to. And again, this is a less than and less than equals to. That's it. So probably we are having almost all the comparison operations covered here for number. Let me give it a try and see. Yes. 100 is greater than 300. No, that's the reason false. Is 100 greater than or equals to 300? No, false. 100 less than 300? Yes. 100 less than equals to 300? Yes, that's true. Is 100 equals to 300? No. 100 is not equals to 300? True. I can see everything is working fine there. Okay. Let me just give it a try one more time. Let's say this is print, and maybe I'll say dash 40 or 50 times. That's more than sufficient. And I want to do the same thing for str1 and str2. At least we can perform some basic operations like is str1 is equals to str2. That's what I want to check. So str1 is equals to str2. Same thing we can check if str1 is not equals to str2. So that's what I want to give it a try and see what happens. Is str1 equals to is str1, that's test1, is equals to test2? No, it is not, because one is test1, the other one is test2. Both of them are different values, so the answer is false. Again, is test1 not equals to test2? True, they are not equal to each other. That's the reason it is true. Fine, understood. Let me try this other way as well. Let me just try to go back here and say is greater than equals to str1, str2, and give it a one more shot and say is it maybe less than or equals to. So probably when I say run, you see that okay, test1 is greater than test2, false. Test1 is less than test2, it is true. It's comparing all the characters there, nothing other than that. Okay. So again, I'll just give it a try one more time and do the same thing here for greater than equals to and less than equals to. And again, greater than equals to and less than equals to. So it is comparing character by character, and it is telling whether it is equal to or greater than equals to, equals to or not equals to, greater than or less than, greater than equals to and less than equals to. It just compares all the characters there. So probably when you think about num1 or when you think about str1, I mean num1, num2 or str2, probably you can see that both of them are number variables or num class objects, and both of them are str class objects. Now probably you can understand that both of them are num class objects, and both of these str1 and str2 are str class objects. You know this. Yes, Adesh, it uses not ASCII, but it uses Unicode characters. I hope you might have heard about Unicode. It's called as universal code, where every character size is not 1 byte, it's 2 bytes. So 2 bytes is it means 2 raised to 16 bits. 2 raised to 16 number of characters can be represented. 2 raised to 16 is nothing but 65,536. So those many characters can be used when you are talking about a Unicode. When you talk about the ASCII, there are 8 bits or 1 byte. So maximum 2 raised to 8, 256 characters can be recognized. That's the reason Python does not use ASCII, but it uses something called as Unicode. I hope you know that. Anyways, so now the point here is both of them are the objects of num class, and both of them are the objects of str class, and I can compare them. See, I can say whether it's a greater than equals to, less than equals to, so on and so forth. I can do that. But now I want to give it a shot for my class. Should I do it here? Let's do it here itself. Let's create a class, maybe a class person, for example. Very simple class, which is going to have, let's say, in it, let's say a name and an age probably. And again, as usual, underscore age is equals to age, and underscore name is equals to name. As simple as that, you know. Just to print the details of my person class, I'm going to say def print info. Or why print info? You know now, right? You can directly override that str method and directly print it instead of creating a separate method for it. So now you can say return and say this is a person. This is a person which is having a name which is equals to self dot underscore name, and having an age, which is self dot underscore underscore age. That's it. Okay, so see what I'm trying to show you here. When you say you are having a class person, I'm going to create two objects of person class and see if I can compare them. I could compare the num classes object, and I could compare the string classes objects, you know. So probably I want to do the same thing for my person class objects. See if it is possible. The first thing is we want to check whether it is possible for us to do it. So let's see, I'm going to create an object of person class saying P1 is equals to person. And this person is going to have the person's name as person1. Person's age is, let's say, 10. Okay. P2, which is again going to be a person of with having a name person2, and age is equals to 20. So we have got two persons. Let us print both of them on console first and see whether we can see them properly. So this is P1 and the type is equals to type of P1. We already have seen this last time as well, but just to be on a same page, I want to print it here one more time. You see, I'm trying to print person1, person2. Everything looks okay. Let me just print this one here. So there'll be a kind of differentiation, like we are now going to talk about the person class. You see, so both of them are getting printed properly. This is my person1, which is having age 10, and this is my another person who is having age equals to 20. Things are looking good. Now, like last time, I could compare an integer and a string class. I want to try to do the same thing for my person class. See if we can do it. In real world, I can see whether one person is greater than or equals to another person, in a sense, based on the age, right? So in real world, we can do it. Let's see if we can do it in this case or not. Okay. To do this, probably I'm going to say, is P1 greater than P2? This is what I want to check by saying P1 is greater than P2. Let's see if it is possible first. If it is possible, then we can go for other. Or why greater do? Let's start with the simplest one. That's equal equals to. In the real world, if I want to say whether two persons are equal to. Now, generally, when we compare two persons, I mean, there are many different ways to compare. I mean, based on the salary, based on the knowledge, based on something, there are many ways. But just to be precise in this context, I want to see, like, can I compare those two persons based on their age values? Because ultimately, when I say one is greater than equals to or one is equals to other, that means whether they are of the same age or whether they are of a different ages. Let's give it a try. When I say run, probably you can see that P1 is equals to P2, which is false. Oh, that means P1 is not equals to P2. Now, what is the reason behind this? There is a reason. I'll talk about the reason in a minute, but see what I'm trying to show you. Let me try to do the same thing with not equals to and see if it is trying to do it here. So when I say run, oh, look at that. It works and it says that P1 is not equals to P2, which is absolutely true. Whenever you are doing this, you always will see the answer is equals to false when you say P1 equals to P2, and the answer is equals to true when you say P1 is not equals to P2. What's the reason? I'll mention that reason in a minute. But before that, I want to go ahead and do the same thing with other type of comparison operators. Whether can I go for greater than, less than, greater than equals to, and less than equals to. See what happens. When I say run, it worked with equals to and not equals to, but it's not giving me any output for greater than. Why on the other it is doing it? Let's give it a try. Let me try the other one. This is not working. Fine. Let's give it a shot for less than and see if it really works there. So probably I'm going to do it here for less than, and so it's still not working for less than as well. It's code 1 means it's not working. You see, it's trying to say that this is not supported. I mean, less than is not supported, greater than is not supported. And if both of them are not supported, that simply means greater than equals to will not be also supported and less than equals to will not be also supported. So what is going on? I mean, I could do that with string class. I could do that with num class, but why on the other it is not allowing me to do it with my person class? Now we have to find out the reason. Before we find out that reason, I want to just show you why you will see the answer is equals to false every time, and why you see answer is equals to true every time for these two scenarios. Okay, try to understand this. I hope you know that whenever you are creating an object of person class, if I just go back here, I don't even have to draw this diagram, but it's okay. Anyways, so this is how we are kind of showing this. You know that whenever you are creating a P1 and P2, that simply means one reference will be created for P1 and one reference will be created for P2. And when I say reference, that simply means both of them will be loaded on different memory locations, you know. So let me just go back here and say this is my person class object. This is my person class object where we are trying to put some information. Doesn't matter what information we are putting here, but what matters here is both of them will always point to different memory location. So probably I'm going to say 0x10,000 here again, like last time. This is the object's location in the memory, which means here also you will see 10,000. And whenever you create one object, it always will allocate it on a different memory location just to identify that object uniquely. So if you create a new object, it will be pointed by different memory location, different memory address. And this is how it is kind of implemented in not only in Python, but also in other languages as well. Whenever you say there is an object, the object always will have a unique memory address so that we can identify that object uniquely throughout the memory. So this is what it is going to do behind the scene. This is going to be my P1, let's say here, and this is going to be my P2. So this is the reason why you always will see P1 is equals to P2 returning false. Yes, this is doing the reference comparison or the variable comparison. Is 10,000 equals to 30,000? Of course not. That's the reason why P1 and P2, both of them will always give you a kind of, the reference equality. This is called as a reference equality. And because it is trying to check the reference equality, it always will fail. It always will give you a false when you try to create two different objects like this. Okay. So that is the reason why it is kind of doing this job of returning false when you say P1 is equals to P2. When you do it for num, again, I don't have to show it, but it's okay. I'm going to show it anyways. So probably I'll come back here and say this is 100 and 100 or whatever it is. Let's say 200, 200, whatever it is, doesn't matter. So what does it do? Probably it goes back here and it creates a separate object for this. It creates a separate object for this. Naturally, their values will be different. 0x 40,000, let's say 50,000, for example, doesn't matter. And let's say 60,000, again, doesn't matter. Both of them will be loaded on a different memory location, whatever it is, but both of them will be having different values. So probably in this case, the value will be different, and that's the reason the answer will be false. So is num1 equals to num2? No, because both of them are having different values. If I say that the value is equals to 100 here as well, so probably if I just go back and put this 100 value here, you will notice that num1 is equals to num2. Are you getting my point? It always will check the reference and will see whether the address is matching for my references. And the same thing is going to happen with the num class references. The only difference is in this case, the value is stored within the same object. And that's the reason why it is trying to compare the value and why it is comparing the reference address or reference equality. That's the reason why it is going to fail every time. Yeah, Pranit, exactly. References pointing to the different objects. Absolutely right. That's the reason why it always will fail. Aniket, your question, we cannot use a less than and greater than on the references. Maybe. Yeah, there is a reason. That's what the reason we are going to find out. Okay. So probably when you say function, sorry, maybe because Python is not discriminating. True. You can say so. Okay, Parag, so if we do a function alias on P1 will work. Let's give it a try. Rather, I wanted you to give it a try on your own, but see if you are trying to do it. Let me say that this is a P3, which is equals to P1. And if I try to do this one and see if P1 is equals to P3. So is P1, sorry, not here, here. Is P1 equals to P3? Let me just try to compare it here. So P3 and P3. And if I say run, you will notice, oh, this is not possible. So let me put this in comment for a minute. And if you look at this one, you will see P1 is equals to P3. You know P1 is equals to P3, that simply means P1 will have exact same memory, exact same memory address of P3, or P3 is going to have exact same memory address of P1. And that's the reason why it is going to give you the answer is equals to true. See, P1 is equals to P3 is giving me answer true because both of them are pointing to the same object. This is the reference object. We already have seen this. It's as good as you are looking at the function alias example. The only difference is the object is not of type function, it's a type of person, but the concept is going to remain same. Okay, so Parag, yes, absolutely true. Even if you're trying to do it with function, that is also going to be exactly similar. Rohit, num1 and num2 are the objects as discussed, so it also have a different references. So it means that it is overriding operator. Absolutely what I'm going to do now, and absolutely you have identified it correctly. Okay. Chandrakant, you are saying in the case of integer, reference objects are stored in the stored into it. Then how it happens? Exactly, Chandrakant. That's what we are going to figure it out here. Okay. Why does it work for string? Why does it work for num? Why does it work for decimal? Why does it work for boolean? Why it is not working for my class? That's the question we want to answer here. Now see the answer. See the secret. You know. So the answer here is pretty, it's not that simple to understand, but anyways, we'll see it. Forget about that equals to for a minute. I mean, I just want you to first understand what happens behind the scene, and then we'll come back and then we'll fix this problem, and then we'll see how to do it exactly like what num is doing and what the string is doing. Okay, first understand this one. When I say, let's do the reordering a little bit, because we are talking about the equal to and not equals to. Let's finish this job first, and then we'll talk about the remaining ones. Okay. So here I want to check like if num1 is equals to num2. Now what happens behind the scene? See, this rule will always be similar for all type of objects. Should I or should I not? That's a question. Okay, I should rather. I'm going to do one thing. Okay, let's do it. I don't want to mess up with this page because there are many things I've added. So it's better we can create a separate page and say, I do have a person class. Okay, I do have a person, I'm sorry, num1 is equals to 100 and num2 is equals to 300. Okay, and I'm trying to see whether num1 is equals to num2. That's what we tried last time. I'm going to do it one more time and we'll show you what exactly happens behind the scene. Is equals to num1, equals to num2. Watch what happens. When I say run, you see that the answer is always no, because num1 is 100 and num2 is equals to 300. If I say it is 100, 100, probably the answer is equals to true. You know that. This is because both of these values are matching. So what happens behind the scene? What happens behind the scene is this. Check this out. When you say equals to, please understand this one more time. When you say equals to, probably it is not going to do it by literally comparing the values like this. It is going to convert this num1 is equals to num2 into this num1 underscore underscore eq underscore underscore num2. Oh, do you remember something I mentioned about that str last time? This is exactly what it does behind the scene. Underscore underscore eq underscore underscore. Eq stands for equal to. Okay, let's see whether it gives me the same result for both of them. You see, it is giving me result true for both of them because writing this and this will give you one at the same result. I mean, both of them are kind of representation of each other. When you say equals to, behind the scene, it gets translated into dunder eq. The same thing is going to happen here one more time. Let's try 300 here like last time. And you see that both of them will give you false. The same thing is going to happen with str as well. Str is equals to test1 and say str2, which is equals to test2. Okay, so let's give it a try one more time. This is star maybe 60, 70, 80. Fine. So if you do, I'm sorry, I didn't mention what this is. So probably I'll have to go back here. I'll say this is going to be my str1. This is str2. This is str1 equals to str1 is equals to str2. Okay, are they equal? Of course not. They are not equal because the values are not equal. If I say that it's test1, you see both of them are equal because both of them are having the exact same value, you know. So what happens behind the scene? the same thing happens. This call gets translated into something like EQ, and then the str will be passed as a parameter to it. So this is how it does the job. Run, and you see that you are getting the same answer here. If I change this test1 to test2, and if I say run, you see both of them are giving you the false result. Moral of the story again is, whenever you are doing equals to, behind the scene, the call gets translated into dunder EQ. Are you getting it, guys? You there, all of you? Are you getting it, what I'm trying to show you here? So behind the scene, you see it's kind of converting this equals to into dunder EQ. Oh, now hopefully you might have got a kind of hint here that if I say P1 is equals to person, and if I say the person's name is person 1 and the age is 10, and if I say that this is person 2, having person 2 as a name, and let's say person 20 as an age, and if I try to compare P1 and P2, so P1 is equals to P2, which is equals to the answer, which is equals to the answer, P1 equals to P2. So what is happening behind the scene? This P1 is equals to P2, which gives me the result false. That simply means behind the scene that must have got converted into something like this. Oh, it says not equals to. It's not equals to just because now the EQ is not implemented by me. The EQ is implemented by default. Yes, by default the object class. That's the reason why it says in your class it's not implemented. It's given, it's kind of implemented by the reference equality. That's a Python's default implementation of it. Okay, so I guess you must have got the hint now. What am I supposed to do in order to literally check whether the persons are equal to or not equals to based on their age and based on their name? So the answer here is, again, like last time we have overridden that method str, we should override the method dunder EQ. Exactly. So we have to implement our own version of EQ. What you are supposed to do here, just check, take a look at this. This is the method that I'm supposed to do. So here we have to return true or false. When I say true, when I say true, it will be, it will return true. When I say false, it will return false. Just give it a try. I know that, by the way, I don't understand. I don't know whether you can understand this or not, but when you say P1 equals to P2 and P1 is, it's getting converted into P1 dot dunder EQ, still we have two parameters. That's P1 and P2. P1 here, on which I'm calling that method, becomes a self, and P2 here, which is getting passed to that parameter as an other, means this is P2 and self is nothing but P1. So basically we still have two objects here to compare. So I'm going to say if self dot underscore name is equals to other is nothing but my person class object, dot underscore name, and is nothing but we are checking both the person's name is same and the person's age is same. Then only I'm going to say yes, the person, both the persons are equals to same. So age is equals to other dot underscore age. So what I'm trying to say here is check if both the persons are having same, having same name and same name and same age. So then only I'll return true or false, you know. So when I say run, see what happens. It says false, false. Why is it says false? Naturally because neither name nor age is matching. Let me try doing this one here. Let me say this is person 1, and age is equals to 10, and you see magically it turned into true. So basically, if I hide my implementation, hide in the sense, if I delete my implementation for a second, and if I say run, you see earlier it was giving me the same answer, false. So possibly when we are talking about changing this implementation or giving the same values to name and age, still it is telling me that they are not equals to, just because Python doesn't understand how you want to check it based on your logic. If you really want to check it based on your name and the age logic, you have to implement it yourself. Python will not going to do it for you. If you want to do it, you have to do it by overriding this method dunder EQ. Okay, so dunder EQ is going to be the method that will get called behind the scene when you are comparing two references. I hope now you understood. I hope you must have understood like why nums comparison works on the value, why str's comparison works on the value, and why by default your reference comparison doesn't work on the value, but it compares only the reference values. I mean references, not the actual values stored in that object. And if you want to turn it into a value-based comparison, how would you do that? So the simple answer to that question is you have to override that dunder EQ method. That's it. Okay. So yes, Utpal, right. Who's that? Vipin, right. We have to override our own method. Or, sorry, we have to override that underscore EQ underscore for our own implementation. Absolutely right. Adesh, yes, conceptually, it seems like we are using an equals to operator for doing something other than what it is meant for. Equals to meant for comparing values, but now I'm comparing my objects based on my criteria, not like comparing values 10, 100, 100 and 300 or test 1 and test 2, but I'm trying to do it with my criteria, checking the persons are same or not based on their names and their ages. This is nothing but we are giving an extra meaning to an existing operator. Existing equals to operator now can deal with my person class object. Few other languages, including Python, says that this is something called as operator overloading. Operator overloading is the concept of giving another name to your existing operator. I mean, looking at this, it feels really simple. But if someone says, oh, this is operator overloading, one might feel a little bit uncomfortable. Actually, it's a jargon, you know. So operator overloading is nothing but giving an existing operator a new value or new functionality. So existing equals to operator works with num, that's in the integer or string or boolean or float or by default, you know. But when you are going to turn it into a one which can deal with your person, then you can call it as an operator overloading. To overload an operator, we have to implement or we have to override a corresponding method. So for equals to, we have to override underscore EQ underscore method. I hope you are getting it. Jagrat, your question, why dunder EQ is not called from the base classes for the person class? First time it will go and find the person, then it should go the base class and it should find the EQ method. Absolutely. I agree with your point, like it should have called that method from base class. That's object class, right? But it doesn't do it. And there is a reason behind this. The reason behind this is because in any language, every object must be considered a separate or a unique object. And to do it, every single reference is going to have a different memory location. Every new object is going to have a different memory location. So every reference is going to point to a different memory location. So behind the scene, if you are not having the equals to, Python doesn't go back to the object class. It tries to put that a kind of a condition to check if it is a reference. I mean, if the references are equal to or not. So Jagrat, there are few scenarios where it works little bit exceptionally odd. For example, reference equality is the basic implementation of checking if the objects are similar or not. And that is the reason why it doesn't go for calling that EQ method from object. So it does call it, I mean, it does have a kind of a hard-coded implementation to see whether the references are equal or not. If you are not implementing your own dunder EQ method, if you do it, it will call your method automatically. Okay, so that's the reason why it is not going to object. It does it by checking the reference equality, not by calling the objects underscore EQ underscore method. Okay. Ketan, can we see an integer and str overloaded methods? Of course, yes. For that, you'll have to download the entire Python source code. You will not be able to see in PyCharm. PyCharm just shows you a kind of declaration, not the actual code inside it. Okay. So download Python source code. You definitely will be able to see all of these implementations there. I hope if you are interested, you will do it. Okay. Preeti, your question. It seems easier than Java. Of course, it seems, it's not only seems, it is it is simpler than Java. Python is the simplest language to learn. You know? Shreya, yes, it's called as operator overloading. True. Vipin, overriding these dollar underscore, I'm sorry, overriding this dunder EQ and dunder STR is recommended or not? Of course recommended. That's what we are doing it here. I mean, provided you need to implement equality and provided you want to return your value in a string format, you have to do it. It's not a question of asking whether it's a recommended or not. It's question of asking whether you need it or not. So if you really need it, you have to do it. There is no escape. There is no option. Okay. Aniket, so is it similar way we can implement for less than or greater than or equals to at the, absolutely right. I mean, what I just showed you for EQ, you can exactly do it for rest of the other operators. I'm going to show you a couple of them in a minute. Okay. Rohit, so default behavior of a comparison is reference equality. Okay. If you're not overriding your dunder EQ method, then by default it is going to do the reference equality. If you are overriding your method, then it will call your method instead. Okay, Prashant, is it also meaning it is doing the method overriding by implementing local method instead of method of object class? You can say so. So probably when you're talking about the equality, yes, it does some magic. I mean, it does some something different than the default implementation. The default implementation is like, if the method is not available in your class, it should call the object class method, but it doesn't do it for equality or EQ because it's a special function. It's a special functionality rather, where you have to check the references in order to see whether those are equal or not. So yeah, that is kind of a little bit different than the others. P2 is equals to P1, print P1 is equals to P2. Try that. Rohit, you will see that it's exactly equal. I showed you that example last time. You are getting any different behavior, Rohit? I mean, are you getting any different behavior? If you look at the last example, I showed you that here. You see, here it is. P3 is equals to P1. So exactly what I said earlier. When you are having P3 equals to P1, that means both of the references are pointing to the same object. You definitely will get the answer true. Okay, but that's again because both of the references are pointing to the same object. Okay, Janika, how does it differentiate user-defined object versus Python objects when calling the dunder methods? There is no difference. It just it just treats everyone on a same. I mean, it just scales every single object with the same measure, so same measurement. So there is no difference. It uses the same technique to call the methods for built-in objects at the same time your custom class objects. There is no difference. The good thing about Python or good thing about languages, they are not humans. I mean, if it is a human would have used a different criteria to measure different things or different people. But here, when I say it's a programming language, it just treats every single object on a similar basis. Okay, there is no difference. That's a reason why I showed you that underscore EQ will work on num, will work on str, and if I implement it on my class, it will work here as well. Str, same thing. EQ, same thing. So basically what num has done, I'm sorry, what str has done, what integer has done, if you do it in your class, you will also get the similar behavior. That's what we are trying to find it here. So Janika, I think hopefully you will agree with me that by default, because these rules are applied to my class, they are applied to the default classes as well. And because default classes already have done their job well, we can use them without worrying about the comparison operator or getting the values out of it, because they already have done their job well. Okay. Deepak, how equals to call EQ method? How equals to call EQ method? Because whenever you are writing the code, it's not like whatever code you are writing here will get executed automatically. It's not going to do it. It's going to modify your code to a different extent. For example, do you remember something? I mentioned this earlier as well. For example, let's say I have a method, say def can vote. I hope you still can recall this discussion we had earlier, where we can check if this same maybe the self underscore let's say age is greater than or equals to 18. So it will return true or false. Okay, so check what happens here. So for example, again, I have two references here to call, or two objects here to call. So if I say p dot can underscore vote, what happens behind the scene is that this call gets converted into person dot can vote, and then it passes that p1. Do you remember I mentioned this earlier? So whenever you are saying p1 dot can vote, it internally will change that to person dot can vote, passing that p1 as the parameter, which becomes the self internally to inside that method. And again, it's not only the Python. In all languages, the same story happens. I mean, the same function is implemented by every single language. Whenever you are writing the code gets translated into something else. The process of transferring your code or translating your code to something else is called as pre-processing your code. So your code gets pre-processed before it starts getting its execution context. Okay, so I hope you are getting the answer. Who's that? Deepak. So this is the answer to your question. Why it does that, or how does it do that? It does that because it translates your code in pre-processing stage. Okay. Jagrat, default class implements for integer other classes, so that's why it's calling EQ. Absolutely right. So if sum removes that method from the default class method, then it will also compare the reference. Of course, yes, but how can you do that? Unless you have the Python source code, and if you are not compiling Python, how will you do it? If you really want to do it, you will have to compile Python's code again by modifying what you are supposed to do there. But your understanding is absolutely right. If someone tries to modify the Python's implementation by removing those EQ methods from their classes, definitely it will again come back to its original comparison, reference equality. Instead of checking the value equality, it will go to the reference equality. Jagarat, I think you got it right. Absolutely right. Okay. Okay, so now I hope you can understand the basic here, that whenever we are trying to call, whenever we are trying to use all these equality or all these comparison operators, by default, they get translated into some of the other methods. And that is a way we can think of implementing those methods for our own criteria. So if I want to see how I can make my two persons equal, or how can I make my two persons less than or equals to or greater than equals to, all we have to use that, or all we have to do is like just override that method and put your criteria. Let's take an example, quick example of it one more time for num, str, and a person. So coming back here, I'm going to copy and paste, not waste your and my time again. It's greater than, for example, or it's less than, for example. Oh, let's do it first. Let's do it for greater than first. Now, when you say greater than, in behind the scene, it is going to call a method called as dollar. I'm sorry, not dollar. It's a dunder GT. Dunder GT is the way we are going to check if num1 is greater than num2. You see that GT means it's greater than, as simple as that. Same thing is going to happen with the str as well. So str is already overriding that method for you. That is again GT. So it's doing its own job. And if I try to run this code, you definitely will see the exact same output. Is 100 greater than 300? No. Is 100 is greater than 300? No. Both of them are exactly equal because both of them are exactly similar. They are doing the same job. I should have, sorry, my bad, guys. I'll have to keep it as it is, and then we'll have to just copy and paste, and then we'll compare both of them. Yeah, that makes sense. Now, both of them are showing you the exact same output just because they are kind of, you can say, one is the explicit operator and the other one is implicit method. So this gets converted into this. Let us try this for our class objects. Now I'm going to try this one. I hope you must have got the idea now. I don't have to repeat the same story again, because if I tell you that this is the way it gets translated, you know that it's not going to work. It's not going to work because we do not have any support for greater than. Okay, we do not have any support for greater than. That simply means check, see, or rather check this method, check this statement, line number 49, and see what does it do. So probably what does it do? It's like it simply says p1 underscore underscore eq. I'm sorry, p1 underscore underscore. The method name is GD. So it's trying to call this method, and this method does not exist in your class. You see, that's the reason why it says greater than is not supported. So for example, if I want to see whether the person is greater than or equals to another person, how do I do this? To do this, all we have to do here is just implement or override the method GT. GT stands for greater than. All we are going to say here, we don't need name here. We can just say if the person's age is greater than the other person, then we can say the first person is greater than another person. Guys, do you understand what did I say here now? So sorry, my bad actually. I should have done it in this way. GT and EQ. Now this is correct. Sorry, I didn't see that which line I was modifying. So now we can say check if the age of person 1 is greater than person 2's age. Okay, so basically what we are trying to say here is, now last time I was getting an error, but this time you see I am able to get the valid answer. P1 is greater than P2, false. Oh, why false? Let me just take a look at it. It seems like the person 1, oh, it's 10 and 10. Let's try person 2 and 20. And still the answer is equals to false. The answer is equals to false because this person is kind of having age equals to 10. This person is having a age of 20. Now, I want to try the other one. The other one is nothing but less than. Now see the magic. This is Python. Python is so intelligent. So probably when you try to compare these two on the other side, I think it's okay not to go for num and str. Are you okay with that? Can we directly go with the person's implementation, or do you want me to show the examples again for every single time for num and str? Can we skip it? Okay, thanks a lot. At least someone is saying something. That's good. So we can directly go for the other one, something like less than, something like a less than, you know. Now, any guess which method am I supposed to call for a less than here? What do you think? Exactly, it's GT for greater than, LT for less than. You see how simple is that? All we are supposed to say here is just copy this, paste it one more time, say this is LT, and all we have to change here is less than equals to another pitch. That's it. That's the implementation what you're looking for. Guess what? When I say run, last time the answer was false because the person 1 was having age 10, the person 2 was having age 20. This time person 1 is less than P2. Is it true? Yes, it is true, because person 1's age is 10, the other person's age is 20. That means this is true. See how simple is that? All we are saying here is, whenever you want to use any comparison operator, you just have to implement that corresponding method and you are done. That's it. So all you just need to remember is the methods mapping. If the operator is greater than, the method is underscore underscore GT underscore underscore. If the operator is less than, the method is equals to underscore underscore LT underscore underscore. Now, see how smart Python is. I mean, not being the Python is a smart, but Python's developer who has developed the Python, of course, Guido Rossum and his team, how smart these people are. Generally what happens here is, and this is a common sense actually, but generally common sense is not very common. That's the reason why we are we and why these people are so great people. Think about this. When I say P1 is greater than P2, and if it is false, what do you mean by that? When I say P1 is greater than P2 is false, that simply means P2 is greater than P1. Do you understand what I'm trying to say here? If the P1 is greater than P2 is false, that simply means P2 is greater than P1. Do you agree on that? And if you agree on that, and if you just see what I just mentioned here, if P1 is greater than P2 is equals to false, that means opposite of it. P2 is greater than P1 is always true. What do you mean by this then? That means you don't have to implement both the methods for getting the answer from both the operators. Even if you implement GT, you still can answer that question for greater than. At the same time, negative value of it will give you the answer of less than. I hope you understand what I just mentioned here. So look at this. When I say run this code, you probably will get the answer for both of them. It's okay because I'm explicitly calling it. Let's not call it explicitly now. It's not required as such because we are going to deal with the operators, not the internal methods. And of course, we are explicitly calling this LT, and that's the reason why it is saying not implemented. Leave it. Look at the less than, and you will see that you are getting an answer for both of them. You are getting an answer for both of them just because you see P1 is greater than P2 is equals to false. That simply means P2 is greater than P1. It has to be an opposite of it. Guess what? If you put this GT in comment and uncomment LT, it still will answer both of your questions. So even if I say run this time, you see if P1 is less than P2 is true, P1 greater than P2 has to be false. This is a common sense. And because this common sense is common with those developers, Python's developers, they already have taken a decision that even if you are implementing one, of course, it will answer the another one just by negating the value. Very intelligent people. That's the reason why they could invent the languages and we are still using them. Anyways, so these are the great people. We just have to salute them every day. So probably this is the language which may give you your next salary or maybe salary hike. So whenever you are learning a new language, always appreciate the efforts these people have taken. Always appreciate the language inventor's thought process, what he has thought of, why the language is so popular, why people are going after Python a lot. See, very very influential persons and very intelligent persons. That's the only thing which I can say right now. Anyways, so coming, let's not be emotional right now. Just get into the context again. So probably this is what we are trying to see here, trying to achieve here. So probably whenever you are trying to say GT, you by default will get the answer for LT. That's true for less than equals to and greater than equals to as well, which means I'm going to go back here and try to do it for greater than equals to and less than equals to. This time I'm going to write the code easily and rather maybe using only one thing. And I hope you must have guessed it correctly. The answer here has to be something like this. What is that? Where is that? Where is that? Here it is. Do you know what should be the implementation I have to go for? Yes. What should I do here? Greater than and equals to GT. So probably I'll have to go for the same thing for LE for less than and equals to, and I hope you must have guessed it correctly. You see how simple is that? So LE, that's it. And probably I'm going to go back here. Of course, it's not going to work right now because you know that the method does not exist. So probably if I just go for implementing one of the methods, or even if I implement both of these methods, still I'm going to get the answer. I'll show you both of them. It's a GE, it's greater than or equals to, and it's LE, it's less than or equals to. How meaningful is that? So less than or equals to, less than or equals to, equals to, I equals to, that's it. So this is what we are supposed to check, and if we do it, you probably get an answer as well. You know, the good thing here is you don't have to implement both of them. Just implement one of them and still you will get the answer of the other. So anyways, you got the point now. So you may implement both of them or you may implement one of them. You still will get the answer here. Okay, so that's how we can implement all the comparison operators, or that's how we can overload all the comparison operators. I hope you must have got the concept. It's very simple. If you have understood the last example, you can easily answer all of these questions on your own. It's very simple. Anyways, I already have mentioned all of these things in your so-called notes. So if you just search for operator overloading, you will find all of them here. Now, let's go for the other one here, mathematical operations like plus, minus, and blah, blah, blah. It's even simpler than this. I think you must have got the idea now. Now you can think of implementing it. You are implementing it on your own as well. But nevertheless, I'll show you one quick example and probably you can go from there. Imagine that I have a class, say class is equals to number. This is not integer, this is not float, this is my number class. So number class, in a sense, we have to have a initializer here so that we can get a kind of a number here. Or let's say a num, for example, which I'm going to store inside a num, which is num equals to num. And probably this time onwards, I don't have to go for a print method. I mean, I can simply implement it by using the str, overriding the str method by saying return. We'll have to go for a number, and I'll say this is having a num value which is equals to num. By the way, again, it's not hard and fast rule that you have to implement it like this. This is just for your understanding. Like this is a kind of a number class object. It is having a number, num's value is equals to this. You may return anything here. It's not hard and fast rule that you have to put the class name and use the same format. This is just for your understanding. Please make sure that you're getting it. I'm going to go with n1 is equals to, number. Let's say this is 100 inside it. And n2, which is equals to number 200 inside it. I'll try to compare them very quickly. You know how to do that now. So all we have to say here is print n1, sorry, n1 is equals to n1 first, as usual, type is equals to type of n1. The same thing I'm going to do it for n2, which is n2 and which is n2, you know. So run this and you will see that both of them are objects of number class. You see, I'm getting a right implementation of it. That's good, but I will not be able to do the comparison here, you know. So if I try to say n1 is equals to n2, if I try to do it, probably, you know, it's not going to work. I mean, not going to work in a sense, it's not going to work on the value equality or value comparison. It will work on the reference comparison. So by default, the answer, you know, it's false and true. But I want to make sure that this is not compared based on the reference. So I'm going to come back here. I'm going to override this method and I'll say return self dot underscore num is equals to other dot underscore num. That's it, as simple as that. So now this is a true value equality. So that's what we have done last time. Very quickly, again, just go back here and try to do it for greater than, less than equals to, and greater than equals to, you know. Very, very, very simple. Let's do the greater than first, makes sense, and greater than equals to and less than equals to. Now we already have made them functional last time. This time I'm going to take a shortcut. Of course, this is not going to work if I try it right now because we don't have any of those methods. So I'm not going to implement all of them. I'm going to implement only two of them. One of them will be greater than or less than, whatever. So probably I'll just go back here and I'll say return, it's greater than. It will answer my greater than as well as less than, so I don't have to worry about it. And similarly, I'll answer this for greater than equals to and greater than equals to. This will answer both of my questions, whether it's greater than or less than, greater than equals to or less than equals to. You see, that's it. It's as simple as that. Now coming back to the main point, you know, I now want to implement the mathematical operators. So I want to go for mathematical operations. Can I do that? The answer is no, you can't. So let's fix that problem as well. So what I'm trying to show you here is like, can I say n1 plus n2 is equals to n1 plus n2? I can easily do it with num, you know that, right? So in case of num, in a sense, in case of integer, it works. But you see, it's not giving me an option to add my two objects, number and number. I mean, though we are having numbers or having values inside them, but still it's not allowing me to add both of them. What could be the reason? The reason is very simple, because this call gets converted into n1 underscore add underscore n2. So probably you might have understood that this is another method now that we have to implement. As simple as that. Coming back here, going back and implement it now. So underscore add. Again, what are you going to return? Now, as per the convention, these methods, all the mathematical operator methods or operations method, all of them should return object of same class. Object of same class in a sense, if I'm in number, I'm going to return a number class object. But while returning the number class object, I'll do the actual addition. So basically, self underscore num plus other underscore num. So that is what I'm supposed to do. If you can look at all the other examples or all the other method implementations, we were returning Boolean value. Could be true, could be false, because these are comparison operators. But when you're talking about the mathematical operators, integer plus integer will always give me an answer of integer. Decimal plus decimal will always give me an answer of decimal. In a sense, float plus float will give me answer of float. And this is true. That's the same reason why we are going to say number plus number should give me an answer of a number type. So that's the reason why we are doing it. Look, n1 plus n2 is giving me a number of value 300. Is that right? Yes, because 100 plus 200 is equals to 300. As simple as that. The same is true for all the mathematical operators now. So probably I'll just go back here and say minus. You know, now the minus is nothing but subtract, and probably you can do it for the rest of the other methods as well. Let's go for star, let's go for slash, and let's go for star, and let's go for slash. You know, probably you know that this is going to be, let's do it quickly. This is going to be sub for subtract. This is going to be mul for multiplication. I hope you can understand. This is a little bit different. So this is depending on which operator you are using. I hope you still can recall we are having two type of divisions in Python. One is slash, and other one is slash slash. Can someone of you quickly tell me the difference between these two? When should I go for slash and when should I go for slash slash? Decimal and fraction. Yes, one is true division and the other one is floor division. Absolutely. This gives me answer in float. That means it's a true division. And this gives me an answer in integer. That means it's a floor division. Okay. Yeah, it's a floor division. Absolutely right. Not float, it's floor division. Absolutely right. So in this case, this is called as a true div. So that's a little bit different. That's a true div for division, which is a true division, and that's a floor div. Okay, so remember that. That's a floor div and that's a true div. Absolutely right. So now let's implement all of them very quickly. You see, that's 1, 2, 3, 4, and 5. Okay, let's come back here. This is going to be a sub, you know that. That's a subtraction. Next, that's going to be a multiplication. Sorry, mul. And this is going to be a multiplication of both of them. Next, it's going to be a floor and true division. So this is a true div. This is the true div slash, and this is going to be the floor div. So floor div. We'll have to write it again. Fine, it's okay. So we can go for slash slash. You know, so that's the way we are going to implement all our maybe you can say mathematical operators. As simple as that. Please try one operator with string. It won't. How can you do that with strings? You know, even if you try to do it with strings without even implementing it, you still will get an error. You see, str is equals to 10, for example, and str is equals to 40, for example. And if I try to say str1 plus str2, and if I try to see the answer, you will see, oh, that's because we are having only numbers into it. Let's try test 10 and test 20 or test 40, whatever it is. You see, it's not going to give me a number addition. It's going to give me a kind of string concatenation, you know. So this is how we are going to do it for string. And you know that for string, plus operator is kind of overloaded to go for concatenation instead of going for the mathematical addition. Please try one operator with the string by implementing. I'm not getting what you want to ask here, Vipin, because this is not our class. I can't just go inside string and implement it for me. It's not possible. Adesh, what if I want to implement my own operator overloading method and wants to call on behalf of that operator, like by default decides method to do it? No, you can't. You cannot define your own operators there. You'll have to use only the operators which are there provided by Python. That's why it's called as operator overloading. In a sense, those operators which are given by Python, then all of them will be a kind of having the default values, and then you can change them. Okay, you're not defining your own here. You are just using different meaning to the existing operators. Okay. Shrikant, how to do n1 plus n2 plus n3? That's pretty simple. Can you see that here? Probably this is again logic. So Shrikant, see if you can understand. Let's say answer is equals to n1 plus n2 plus n3 plus n4. Let's add one more bonus, you know. So see what we are going to do here. N3 and n4 is not there. Not a big deal. I'm going to create quickly. Okay, so this is n3 and n4. So n3, n4. So this is going to be 300, is going to be 400. See what is going to happen here. So when you say answer, I hope you can understand this call gets converted into first answer is equals to n1 plus n2. So these two will get added plus n1 plus n4. I'm sorry, plus n3 plus n4. So whatever is the answer of n1 plus n2 will be replaced here with the actual answer of n1 and 2. For you, I'm going to mention that answer 1 and 2. Okay. Then these two will get added and the answer will be replaced here by using answer 1, 2, and 3. So first, second, and third will get added. And finally, you see that is going to get added like this. See, plus, minus, subtract, plus, minus, multiplication, division, all of them are binary operators. Binary means only two operands will be used at the time. So probably it will start from the left to right. So it will get first two, we'll add them, and whatever is the result will get added into N3, or N3 will get added there. Whatever is the result, N4 will be added there. I hope you are getting it, Shrikant. Okay, this is exactly similar to 10 plus 20 plus 30 plus 40. So how do you do that? How do you perform this? You first add 10 plus 20, which becomes 30. So 30 plus 40, and exactly the 30 plus 30 becomes 60, and now 60 plus 40 becomes 100. So if you can understand this, you can easily understand what it is doing here. So it's not going to be it's not like it's going to call it's not going to call the method for all of them at once. It's just going to do the addition of these two first, then the answer, and then N3, then the answer, and then the N4. That's how it is going to do it. Yeah, internally, exactly. Python will do it internally. That's because plus operator here is binary operator. Okay, that's why it is going to do it. Okay, so Shrikant, I think you got your answer. Vipin, what we did with the numbers, can we do it with the strings like our own concatenation? Yeah, okay, you are talking about that. Yes, what we did here for numbers, you can do it with the string, because ultimately the control is in your hands. Whether you want to do it with numbers or strings, it's up to you. Okay, so yes, you can. Absolutely, you can. Ketan, can we overload the string operators? There is no string operator as such. The one which you are using here, these are all mathematical operators, and str class has overridden that method or overloaded that operator for string operations. For example, plus is already overloaded by string class to do the concatenation there. Okay, so there is no special string operators as such. String class has overloaded those operators for its own use. I guess you are getting it now, Ketan. Okay. Okay, Adesh, so why can't use ARJS as a parameter of the dunder method for addition and multiplication numbers? It's not like why, it's like how. I mean, you can't ask the question like why, because they already have decided that, you know. The method which we are calling right now, this method is going to decide how many parameters are there. In a sense, if you want, you can turn it into your own method, but if you want to use the default operators, those operators are binary. When I say binary, there'll be only two operands. How do you add two members? How do you do the addition? You do the addition by adding only two numbers at a time. I hope you can answer that question, Adesh. Right? So how do you do the addition? You add only two numbers at the same time. Even if you want to add 4, like I showed you an example here, even if you want to add 10 plus 20 plus 30 plus 40, you just don't add all of them together. You first add 10 and 20, whatever the answer comes, then you add 30 into it, whatever the answer comes, then you add 40 to it, and then you get the final answer. So even if you are doing it in the real world, you still are following the same technique. That's what Python is following. So that's what Python says. When you are using these mathematical operators, all of them are binary operators. And when I say binary operators, that simply means they will accept only two operands at a time. Okay, so that's how it does the job. Exactly. Ketan, it will add on exactly. So it will add a plus for every two operators, like 10, 20, then whatever the answer here, 30, 30, then whatever the answer here, 60, 40. That's it. That's how it goes. Okay. It's like assembly language A equals to A plus B. Absolutely right. Opcode. Exactly. Add opcode. True. Okay, so now I think you are getting an idea about what operator overloading is, and probably we already have overridden all the operators. I didn't show you these two. If you want, you can go ahead and do it on your own, because hopefully you can see that star means it's a power of use underscore underscore POW underscore underscore pow. That's power, and percentage is nothing but the modulus mod. So try them, and hopefully you will get the result what you're looking for. Okay. So probably your notes is already having all the operators which we can overload, and probably we already have overridden all of them. So hopefully this is a kind of an idea you will get now, that how you can give the extra meaning to your existing operators. This topic is called as operator overloading. That's it. Anyways, I think today we have looked at the method overriding explicit, or maybe the real-time examples with a kind of method or operator overloading. Utkarsh, you are asking a wrong question at the wrong time. What is floor division? We have seen that in first or second lecture. Floor division is the one which is going to give you the integer value instead of giving you the float value. Try to do it. maybe do it by 3 divided by 7. See the answer. Oh, sorry, 7 divided by 3. See the answer for slash and slash slash. You will understand yourself. One is going to give you the float answer. The other one is going to give you the integer answer. Okay, that's the only difference. Ketan, so multi-threading in core Python or packages coming it maybe tomorrow, not tomorrow, day after tomorrow, or maybe we'll see. But yes, there will be one example of multi-threading. Okay. Anyways, we'll talk about that. Actually, it's an OS package, so we'll see that later once we know the modules and packages tomorrow. And probably starting from tomorrow, we have to start diving into all the packages like I mentioned earlier. Okay, so be ready with that. Anyways, I think that is it, guys, for today. Tomorrow we'll start talking about the modules, packages, and different type of modules. Maybe we'll start talking about something like the default or the simple modules like OS and other things. And maybe probably we'll talk about the advanced modules starting from day after tomorrow. So probably again, as usual, thank you very much for attending today's session. I'll see you tomorrow exactly at 8 o'clock by the same time, on the same time. By then, have a very great day ahead, and yes, be there tomorrow. I see the count is getting reduced day by day. So be there tomorrow. You will see the models and packages. Anyways, till then, bye-bye. See you tomorrow. Bye-bye.